Are we recording now? Ah,
Yes.
now we are. Okay. Very good. So, I guess this is then the official first episode. Well, in full disclosure, we did a smaller, well, it wasn't small, but it was a 2 hour session as well last time to understand what this was going to be. So, yeah, I think we can maybe give a little intro as to what the podcast is about. I think maybe Erik, you want to give it a you want to give it a go?
Sure, at the intro. Um, so we're just two friends who like the book. For the record, Thomas, you've read the full book of David Deutsch.
Indeed.
I'm running through it, so I'm reading the chapters as we go with this podcast, and I'm like on a journey to discover the book, what it means, and I'm happy to discuss it with you. So we're gonna run through, all the chapters of the book, and we're gonna try to time it in such a way that one podcast episode is one chapter of the book. Anything else that we want to add to that?
We have, I think, humoristically dubbed it Erik correcting Erik for now.
Yeah,
And I think indeed the hour will be a good way to make sure that people don't feel overwhelmed by the time if they want to get involved with understanding the concepts. It's not meant to be a substitute, obviously, for the books. It's meant to be, well, it could stand hopefully by itself in a sense, just because the concepts stand by themselves. But obviously, the books are still the best place to go to if you want to understand it more.
yeah.
Cool.
I think that we also hope that we can inspire some people to read up on the book or to at least check some of his YouTube videos, his TED Talks. And if people think that it's very interesting, that can be a stepping stone to actually starting to read the book.
Exactly. And I think maybe as time continues, or as we um, have people reaching out, maybe we can add some like referencing material in whatever the functionality of link sharing could be. Because I know there are some YouTube channels out there that kind of
Yeah,
consolidate all of Deutsch's stuff out there. Um, and then once you pull the thread, really, there's just an infinite amount of knowledge out there to be gathered, both in the philosophical sense and in the actual sense here. Um, um, the tangible kind of practical sense.
yeah. All right. I'm curious to go on the error correcting journey to accumulate knowledge about practical stuff and philosophical stuff. Yeah.
Love
So let's
it.
start with actually the title at the beginning of Infinity, because it actually it actually summarizes, in my opinion, um, the entire premise of his philosophy and of the book. So what does that mean according to you? The beginning of Infinity.
Yes, the title in itself is a masterpiece almost, in the sense that it does capture the essence of what underpins the entire, let's say, philosophy or epistemology, is that we are always at the beginning of infinity. And the best way to look at that is to think about an infinite set of numbers, right? Let's say let's take what they call a countable set of numbers, which is like just the integers, right? 1, 2, 3, 4, 5, and so forth, and then up until infinity. Now pick a random number between, 0 and infinity, right? You are still infinitely far away from the end of that infinity. So wherever you are on your journey to infinity, you will always be infinitely far away from the end because there is no end. So if you imagine yourself standing on, let's say, a ladder of knowledge, and every time you discover or you make a new discovery and you kind of go on to the next ladder, you will still see an infinite amount of steps in front of you, no matter how far you go. And I think some people listening will think, oh, that's kind of depressing, but it's not. It's actually the opposite. It means that progress is infinite in its core. It means that if you would, for example, if you would say that progress comes to a halt at some point, that means there's nothing left to be discovered. There's nothing left to solve. No problem left solving. No problem even could occur because they've all been solved. And that is just not true. You can always, well, create, well, you encounter problems and then you go out to solve them. And that process is infinite.
Right? Does it also, it's about problem solving. There's also a good link to like scientific explanations. And before we go into what's a good and a bad explanation, how would you relate the title to the the infinite character of science and explanations?
It would be the same, I think, in the sense that every let's say every solution is is a creative endeavor that is meant to solve that problem, that specific problem, and you need knowledge to solve a problem. And it's like you would say, um, maybe a very now kind of topic is like global warming, in a sense,
Mm-hmm.
right? Everybody thinks, oh, it's such a problem that, it's the melting of the ice caps, the temperatures rising, and yes, those are problems, but they're soluble. And we only got to this stage because we were able to create technologies that could transform raw materials into energy, that could power cities, that could, sustain more people, and so forth, up until a degree that that's actually a more interesting problem to solve than it is people dying from starvation because we're not using the energy we have to keep the people on this planet alive. And and maybe this is a little bit running ahead of ourselves in this conversation, but that gets into moral questions as well. Like people that do say that humans should not be interfering, and if there's a natural ice age, then let that natural ice age come, in a sense. But then why wouldn't we try to stop that natural ice age from occurring as well? So again, you have to rationally look at these things. And if one applies the philosophy that all problems are soluble, which is the optimistic or the optimism embedded in Deutsch philosophy, um, you will always just be solving the next problem. And that's, in a sense, also what a person is and the person does. It's just a constant problem solving machine. Um, and that to me is just a beautiful thing, because if you would put a limit or a cap on such a progress, then you're effectively, what you're doing is you are claiming that there is something that we cannot understand. You're claiming that there is a concept, a problem that is unsoluble, which means that it's beyond our ability to explain it or to understand it, which basically says it's the God argument in a different in a different coat, right? As we like to say in the Dutch literal translation. It's just the same thing. You're invoking the supernatural, basically. So the book really is to provide pushback against what is supernatural explanation minded like thinking, as well as invoking a deep connection to what we are as human beings. Because that's what you see also that happens throughout the history, is that we've almost become racist towards ourselves, humans, right? Like humans see themselves as parasites, and view themselves as bad on this planet, and somehow think the world would be better off without us, which is such a horrible thing. Like, which other species, isn't trying to solve their own problems? But somehow when we try to solve our problems, that's put in this kind of negative light, right? Where somehow we shouldn't be. I don't know. Like, it's like we're not part of this planet, in the sense. It's like we are. It just doesn't make sense. It's not rational. And that's also what I love about this book, is it doesn't put us back in the center like the God era did, where we had a special place in the, like, we're created by God, and we are the number one. Kind of that special religious sense that I think the current trend pushes back against that, where we're like, guys, let's not be so, let's not be so what's the word I'm looking for, like elitists about ourselves. Like, what's special about us? We're just also animals on this planet doing our thing. And in that sense, I agree, but I also disagree. And that's what David Deutsch is trying to also provide a different philosophy for, because if you do not replace the void that exists within these new generation of so-called self-proclaimed rationalists, because they don't have that same philosophy that the religions offered, in a sense, there's a void there that needs filling, and that gets filled with pessimism now. It gets filled with people thinking that humans are bad, are evil, and somehow society is evil, and corporations are out there to get us, and you get into these doom thinking scenarios, and you get into these prophecy like scenarios, and science is actually abused, in a sense, to make sure that they are, serving the current narrative that some doom thinker or doomsayer has proclaimed. So, and I know I'm kind of touching on a lot of different things here, but it is to that regard I feel the void is being filled here by offering and putting us again into a central, not a central role in the sense that somehow we are like gods or something, but it puts us in a position where we actually are able to solve more problems for everybody, including the other animals on this planet.
Yeah, we're the only ones saving the pandas.
That's true. That's funny, right?
Yeah.
I mean,
Yeah,
somehow we are both the worst and the best at the same time, and everybody likes to invoke this mass extinction that's going on that supposedly we are causing, and as if that extinction wasn't a thing before we were here. Like, extinction is a natural event. It happens if the organism cannot adapt to the changing environment that it's in, or that the gene just cannot replicate, because that's the core of neo-Darwinism. But now we're definitely I think going a little bit beyond the scope of this first episode. But so to wrap it up,
yeah,
it is a philosophy of optimism that puts us in a central way back into the picture, in a like not authoritarian way, but in a way that we understand and are wanting to be more understanding of reality without getting lost in what is postmodernistic, hyped up intellectual, definitional arguments about what is consciousness, what is not consciousness. This philosophy makes it about solving problems, and there is no better or worse problem than one or the other. Every problem is your own to solve as well. One of the best quotes, actually, I read about, I think, was it Popper, who said, let me just pull this up here. He said, the best thing that can happen to a human being is to find a problem, to fall in love with that problem, and to live trying to solve that problem, unless another problem even more lovable appears.
I think that's a really beautiful philosophy. I like it.
Yeah, I like it
Yeah,
too.
cool. All right. Yeah. So that's the implication of the title on the book. I also have some reflections on that, but I think they will be closely linked to good and bad explanations, and we're going to talk about that for a second. So there is a reason why we're talking about this book. You like it, I like it. So it has had an impact on our lives. Yeah. And I shortly want to talk about what the impact was for you and for me. And I'll first explain mine. So for me, in the past books that I've read, there were always a couple ones that had like a mind-blowing insight, that made you really think about reality in a different way. And just to give you a couple of examples, I think about 10 years ago, I read Stephen Hawking's, and there he explains an experiment that when you're in a rocket ship and you shine a flashlight forward and the rocket ship is close to moving at the speed of light, and you shine a flashlight to the front, that light, even though you're already traveling at the speed of, almost traveling at the speed of light, that light will still go at the speed of light. But then if you would add those two up, it wouldn't make a lot of sense. So something's got to give. And that was the first explanation, the first time I read about that time doesn't really tick in the same way everywhere in the universe in every situation. You know, if you're going faster, time goes differently. And so a second on Earth is not the same as a second near the sun. And the same not only goes for your velocity, the same goes for supermassive objects. If you're near a supermassive object, it actually warps time. And we see that in the Interstellar movie, where the characters are close to the black hole and they come back and they've been gone just for like 10 minutes and then 8 years have passed. So that was for me a first mind-blowing insight that I ever read. And the second one, we're not going to talk about that today, was a double slit experiment. I think it's very interesting to discuss it in a different in a different segment when we talk about the multiverse. Yeah. That for me was a second mind-blowing insight that, the multiverse is actually part of our reality. And then when reading David Deutsch, the power of knowledge and the impact of knowledge was for me also an eye-opening insight that made me think about reality and people and how we behave and everything that we see around us in a completely different way. And that's why, for me, it's such an interesting topic to talk about. So are there any mind-blowing insights from the book that you would like to share in this intro?
Yeah, absolutely. And just before I do that, I just wanted to kind of maybe tag on to what you said there, is that one of David Deutsch's quotes in the book is, I think this is the Fabric of Reality book, not the Beginning of Infinity. So he has two books that he wrote, and I've read both of them. And one of the quotes there is that says, "Our best theories are not only truer than common sense, they make more sense than common sense."
Yeah.
You know, like, let that sink in for a while, right? It means that, you know, to me, first of all, intuitions are a thing of the time in which you live. It wasn't obvious before, you know, relativity theory was there, that there was such things capable of, you know, GPS, right? And nobody would have had the intuition to phantom GPS in let's say Aristotle's times or something, right? So even in highly religious cultures, you know, intuitions are wrong, and because they go based on knowledge that culturally has been accumulated and then needs correcting. So if you can allow for the process of error correcting, you will actually always have that progress, which is infinite, right? So I wanted to note that because it has to do with what I call intellectual vertigo. You know how vertigo is like when you're, you know, that when you fall, right? And I call it intellectual vertigo, is where you have that intuition shattering moment, where just everything goes like, you know, like, oh my God, really? Like that's real, and it just makes you rethink and reorient and redefine what reality is, right? And that to me is also one of the things I am, let's say, almost addicted to, which is why I go on these, you know, manhunts for knowledge, philosophical knowledge, and kind of the interstellar knowledge as well, because it, you know, it helps you frame reality, right? It does guide you, right? Anybody who would say like, why do that? That's precisely that in that question even is packed a philosophy, right? You can discount the role of that, but you're still doing it, in a sense. So yeah, I just wanted to add that. And for me, what was mostly necessary in kind of in my search was that I was kind of falling a victim to seeing humans as these kind of parasites, and, you know, seeing us as evil kind of things on this planet, and like, what's this global, also like the global warming hoax, almost, I want to call it, and I know these are sensitive subjects, but in the sense that, not that it's not happening, but how the community, the international community, is going about trying to solve that problem is just based on groupthink and isn't rational. So this book really was my therapy. It brought me back to optimism in a sense, but like rational optimism, right? Not just assuming everything will become good. And Deutsch is the first guy to say, like, there's no law of physics that says that progress needs to continue. It just can. I think that's a very important kind of thing to discern from each other. Those two philosophies, because I think a lot of people think, oh, it's optimism and you're being naive. Like, no, that's actually not what's happening. So yeah, that's kind of my intro.
Yeah, cool. Yeah, as we talked about it before, it brought you back to to positive thinking. Yeah. He redefines optimism as critical rationalism. Yeah, and I would like to talk about that. What that means. Yeah, but before we dive into that, what I think is really important is that, because we talked about philosophy and so on, and usually when we have discussions about philosophy with people, they always say, "Oh yeah, it's something to think about on a Sunday afternoon with some tea when it's rainy outside, when you have nothing else to do. You know, it's fun to have some thoughts about philosophy and do some thinking, and it doesn't really have a lot of practical day-to-day implications." But I believe that this book is very different, you know, and this critical rationalism philosophy can have a lot of day-to-day implications, yeah, on your decision making. So can you run us through some examples of how this book has affected your life, and how maybe others in your environment?
So I guess if you go out thinking, so everybody has a philosophy. Again, like even if you want to discount the fact that you don't, you still have it. It's maybe more implicit. You haven't thought it through. You haven't like written it out. It's an intuition that you carry with you. But there's still let's say knowledge in there. You're still carrying even cultural knowledge baggage with you, from your mom, your school system, kind of the dogmas and the indoctrinations perhaps that you've gone through in maybe a socialization, schooling system as well, is where it's very often that people are taught things. And so once you come in with this preconception of kind of how life is and how the world works, that's your philosophy, right? No matter how you want to turn it. And if you're open to the fact that that could be wrong, and you're open to the fact that there's something that you're always wrong, basically, and you're just trying to get better, that to me is a healthier way to stand in life, rather than kind of just digging yourself into a belief system, just because there's maybe some trauma that got accompanied with that, and it's something that needs to be true for your. I don't know. I'm not a psychologist, so I can't really speak to those to those dynamics. But I think there's something in there that just makes the brain very non-adaptive to certain changes once they've become ingrained. Once certain ideas have become ingrained and become part of the social fabric, you actually, you would maybe jeopardize your social status, right? So there's sometimes an incentive to just continue with a mindset of the group, just to be part of it. And we are social animals, so we do value that. So I think having an understanding that you should be able to adapt and change your mindset as you go through life is just from the baseline. There is a healthier stance than kind of having these dogmas, right? So it has impact on everything, every day to day. So I wouldn't even be able to pick out one specific thing, but I'd say it just impacts my willingness to see that I'm wrong. If not externally, at least internally reflecting upon it. Maybe not admitting it in certain moments, but I do. You do take it with you, right? And you do make it. I mean, you try at least.
Yeah, if I understand it correctly, and if I can summarize that, even though if let's say you're not religious and you don't spend a lot of time on philosophical thinking, you do have some social norms, and not only that, but some personal preferences that guide your daily life. So let's call that your personal philosophy. Even if you never thought about it, you have your intuitions, your habits, your dogmas, your beliefs. Yet again, even if you're not religious.
Yeah.
And a lot of people, I think, they see that as like the truth and the way to go forward in life. And I think the philosophy, and that's what error correcting means, is that we're never always right, the best version of ourselves.
Yeah.
And we should always try to make ourselves just a little bit better every day.
Yeah.
You know, as a human being, just as we expand medical knowledge a little bit better every day, as we understand our environment and the way we can be climate neutral, the way we can make that better every day. So I think it applies on, to summarize it, on yourself and how to become a better human as well. Is that correct?
And your ability to solve problems, right? I think just understanding the problem and defining the problem and having a solution for that is critical, and knowing that you're talking. So I mean, there's a lot of stuff in here that goes into like the expert problem, where you have these scientists that during Corona times you saw this right happening, where they'd come out and they say, wear masks, and
Yeah.
And then it became a political thing. And I remember us as well in Europe just thinking, fine, let's just put on the mask and be done with it, right? And there was some kind of intuition why the mask worked and what happened, but that again was like in you're assuming in this non-realistic sense that the masks are being replenished and people are changing them, people are putting them on the right way, and that's just not reality. So David Deutsch actually on Twitter, who was like constantly saying to kind of shouting out from his accounts, like saying, we don't know what the impact of the masks are. We just don't know. It has, maybe they work, maybe they don't. There is reason to believe that they work, but there's also reason to believe that they won't work, considering the reality of how people use them and those nuances. So while everybody was kind of shouting at each other for being anti-vaxxers and all that stuff, right? Like you could really see that there was this expert it's almost like in a religious sense, right? They became bigger than the politicians, because the politicians could point to them and say, whoa, we're just following the science, guys. It actually took away responsibility, and politicians love that. They don't have to take responsibility for stuff, because they can go for re-election then again, because they didn't make the mistake, because it was the science, which is also what Deutsch is, I think, tries to give us in this philosophy, is that nobody has a claim to better knowledge than anybody else. There is no such thing as the dude with the knowledge, or the person that has the knowledge, and that it's about the ideas, it's about the explanations, and they should be verifiable. You should be able to test somebody's ideas and explanations, and you should have a conversation about that. And that's what you often see in religious cultures, where some things are just not up for debate. And when something is not up for debate, progress halts, because you cannot criticize that thing, therefore no progress can be made. And Deutsch frames it also in the, he says there's like been the mini enlightenments, once in a while, but really when the British Enlightenment started, and that we didn't have, like you had knowledge for the sake of knowledge and for the sake of scientific thinking. You didn't have it for, because the God said it. That really propelled forward every innovation that you see today. The reason why we can have this conversation through these technologies that we're currently talking through.
Yeah, exactly. And I think that needlessly brings us to one of the first big topics in the book, because we talked a bit about what does it mean, what is the impact, what is the general premise on the book, what are the general concepts. So let's dive into the first big concept, And you kind of touched upon it a little bit. A good explanation and a bad explanation. It's one of the first big things that is explained in the book, and no pun intended, with some practical examples. So let's dive into that one. Can you give an example of a blatantly bad explanation?
Yes, and I think as always, it's good to start with a good quote, right?
Yeah.
So I think he uses the example of Churchill in I forget where in London that is. It's in Parliament Square in London, and I was there not too long ago, and I saw the statue, and it reminded me. I actually took a picture of it, and I used it as a post. And the premise is as follows. So consider, and I'll just have the part of the book here. I'll read it out. So consider one particle. Consider one particular copper atom at the tip of the nose of the statue of Sir Winston Churchill that stands in Parliament Square in London. Now, let me try to explain why that copper atom is there. It is because Churchill served as Prime Minister in the House of Commons nearby, and because his ideas and leadership contributed to the Allied victory in the Second World War, and because it is customary to honor such people by putting up statues of them, and because bronze, a traditional material for such statues, contains copper, and so on. Thus, we explain a low-level physical observation, the presence of a copper atom at a particular location, the nose, through extremely high-level theories about emergent phenomena such as ideas, leadership, war, and tradition. So as I'm reading through this, actually, because I'm also still a student of Deutsch's philosophy and his teachings and just the critical rational way of thinking, basically, is that it is such a hard to vary explanation. You have to invoke culture. You have to invoke war and social, like there's the social aspect. You have to invoke the bronze metals being available to build those statues. So the components of this explanation, if you remove one of them and you say there wasn't a war, then you can't explain the copper atom anymore on the nose. And maybe that's a little bit too soon, too much for people getting into this, but I thought that was maybe a good teaser. But then coming to maybe, let's say, a more realistic or kind of easier way to think about this is in terms of the easiest way is always like science, because scientific theories are very crisp, they're very clear. Social language and like habits and behavior aren't always. So it gets a little bit more ambiguous sometimes, the language that you use. So it's always easy to use scientific ways or scientific theories. In this case, if you'd say, for example, Einstein's relativity theory, E is mc squared, for example, let's use that one for now. By changing one of those things, if you change c, which is the constant of the speed of light, into something else, the predictions don't hold anymore, right? If you change mass, which is let's say the kilograms of unit measure that you can have through a certain measuring protocol, which makes me think, by the way, there is the philosophy of measurement as well. Measurement in itself is a philosophy that one applies to kind of scientific things, sorry. And they call it the measurement problem, which we can discuss in, I think, 20 podcasts from now. But so to come back to the example, it's because if you vary one of those things, the thing doesn't hold anymore. It's bad. It doesn't give you the prediction. It doesn't have the same explanatory reach. It doesn't have the same ability anymore. While, let's say, often is in any godlike story that we know from our past or history lessons, is that the Greeks obviously have a lot of these examples where you just say, hey, Greek Aphrodite or Hermes did this and that, and she cried, and that's why it rained, and that's why the crops are there, or it's a red moon because blood was spilled by the gods or something like that. So all these things, although in itself are technically testable. I mean, an explanation is not bad because it is necessarily you invoking. It's not because you invoke God that it's a bad explanation. It's because the concept of God is interchangeable with anything. That's why it becomes a bad explanation. It has nothing to do with looking down on religion or thinking that somehow, they're also not trying to solve a problem. They are. They're it's just a bad way to do it because you can swap it out for anything else. And I could have explained this better.
Yeah. So to summarize that, a good explanation is something that is hard to vary. E equals mc squared. You cannot just interchange or exchange any of that component into another one. It wouldn't work anymore. And to go back to that God example, the one that I really liked is the sunrise and the sunset example. So I believe it was the ancient Vikings who had an explanation, or Norse cultures, for sunrise and sunset, where they would say, oh, every night there would be some kind of godlike wolf chasing away or eat whatever is causing the light, and then every morning it would come back. And that's what causes the sun and the moon, sunrise and sunset. But you can change the concept of the wolf into anything. You can say, oh, it's not a wolf, it's a snake, or it's I believe the ancient Egypt. They had a different story where every night, I think it was the sun god Ra who had to fish back in the sun from whatever. I don't know how it works. So you can just exchange that into anything. Yeah. So that's a bad explanation. It's not because it's a religious explanation that it's a bad one. No, it's because you can, because it's easy to vary. You can swap it out.
And you could just, again, like it's the testable theory in a sense, right? In let's say the Vikings case, if you kill somebody, maybe the sun goes up, and let's say one day you don't kill somebody, the sun still goes up in the sense, then you could always just say, you could just invent another reason why the gods did it then in that moment.
Exactly.
For another reason. You could just keep adding at infinite godlike reasons without actually explaining the thing, which is also kind of what Occam's razor is about, where you have the more simplest version of an explanation is the better explanation. Because if you can do it with less moving parts, if you will, then why not do it with the less moving parts? Why add stuff that's not necessary, right?
So, yeah. Exactly. Yeah.
Yeah.
So now that we understand what a bad explanation is, we can always talk about good explanations and then better explanations, because I believe that's also an important part of David Deutsch's philosophy, that there's always a better explanation. There's always a better solution to a problem or a new problem. And if we take the sunrise and sunset, you can say, well, every morning the sun rises and every evening it sets. It goes up and it goes down. And that's kind of an explanation that we heard as kids, and that was kind of it. And that's kind of how it works. But that's not how it works. There's nothing going up. There's nothing going down. There's nothing rising. There's nothing going down. The better explanation is because the Earth orbits the sun, and because the Earth rotates on its own axis, like every morning, the Earth rotates towards the sun. So we see, it appears that the sun is going up in the sky, and we have the light. And then in the evening, the Earth rotates away from the sun, from our point of view.
Yeah.
And so it becomes dark. Yeah. And that's a better explanation to, it goes up or it goes down or whatever.
Yeah, but mind you, though, that there's often still a nuance here that's made, because what if you're not in let's say Belgium, where we are, and you're you're near the North Pole where the sun doesn't set? What explanations do those ancient tribes create, right? What do they say from left to right? Circular? I mean, it has to do with the fact that there is no such thing as an observation that ties to the explanation. The explanation comes first. You conjecture an explanation, then you test it against reality. And that's what happens. So the sun going up or down in itself is not even an explanation. It just purports to describe, in this sense, the sun, which, by the way, you need to have an understanding of what the sun is first, also, because in the ancients they thought that, for example, the stars were just like light candles, very, very low radiant, low temperature things, and now we know they're giant, nuclear fusion bombs, like just massive things. So even from that perspective, like it doesn't mean that you need to try and explain it first. You need to have a theory for what a star is. You have to have a theory for what the sun is. Then you need to have a theory for what could cause the observational things that you're purporting to explain away. But without going into it with an explanation, you have them implicitly. If you're doing something, it's not because you can't describe it. It doesn't mean that you're not doing it. I think that's also a misconception that people have. Is it's like, can Federer explain how he does his magic tennis playing? I mean, he has some idea, training, nutrition, right? There's some basics, but can he really like put to words like how he does it? No, because it's a very implicit knowledge. It's like riding a bike. It's implicit. You need to make that those two things need to be taken seriously, but separately as well. But it's still knowledge. You just have explicit knowledge, you have implicit knowledge. So even if people purport to say, yeah, but I see it go up and down, there's so much that's packed in there. You're assuming already a lot of things about the language that you're using. I mean, vis-a-vis the observation, which has the explanation first, and then comes the explanatory part. That's, I think, what Bayesians get wrong, in a sense.
Yeah, I also think that a lot of people confuse the observation with the explanation. Like the sunrise, in the sense that it's just the observation, but it doesn't explain anything. We need all the other stuff to explain. And you can go a lot. You can go very far, because you can explain motion of planets orbiting the sun, but that doesn't explain why the sun gives light. There you need knowledge of nuclear reaction and energy conversion and mass into energy and so on and so on. But I think that needlessly brings us to like the next part. So we've talked about good explanation, bad explanations. Yeah. But of course, the scientific method therein is a very powerful tool to create good explanations, because we can measure things, we can verify things, and then we gain the knowledge and we seem to know things. So we can test how the sun works, and then we can test it again over and over again. And if we test it 100 times, 1,000 times, we kind of figure out how it works. It's the scientific method, empiricism. But David Deutsch, he has a very critical thought about that. In his mind, it is not always right. And that, for me, that was also a bit mind-blowing, because we both come from a scientific background, and then suddenly we learn that, wait a minute, the gold standard scientific method, according to Deutsch's philosophy, is not always right. So how would you go on to explain that?
So to unpack a couple of things there, the philosophy of empiricism, right, I think it says that you can somehow read the book of nature. You can somehow, and it's always good to use examples. Sorry, and I think let's use an example of the water boiling. I think that kind of ties in empiricism and Bayesianism. And empiricists, what they'll say is, the scientific method, you have to test. And let's say the more you test it, and the more your predictions match your explanatory framework, the more sure you become, right? So feelings start coming into the equation. You're confident about something, or you're not confident about something, and then you get into these confidence levels and sigma levels and statistics and all that kind of stuff. which is, again, like, why would a confidence level, what does that imply even? It's often that there are implicit assumptions that are not made explicit. Because if you challenge people on their confidence levels, they will come up with, again, reasons, explanations, not the extrapolation of the original thing, in a sense. So a good example would be the boiling point of water, or let's say the phenomena of water boiling. So let's say you draw a graph, right, and you plot the temperature of water over time. So just a simple two-dimensional graph, time on the x-axis and temperature on the y-axis. Let's say you run that experiment for water 90 times, then, but you never get to 100 degrees. Let's say for some reason your machinery doesn't get there. You don't have the technological capabilities yet to do that in this thought experiment, and you only get to 90. Now, a Bayesian thinker and empiricist would say, oh, I see a trend here. Look, the line is going steadily up. What do they assume? They think, oh, it will go up forever, right? So they will actually extrapolate the observation to, whatever the future is, because they've assumed that that trend will continue. Then comes in boiling points, where gases come into play and this whole new realm comes into play. So the analogy here is meant to show that it doesn't work. You cannot extrapolate into something that you don't know, because you need the explanation to be there before. So the explanation of boiling points of water, they have, the H2O molecules, how closely they are together. It has to do with gas laws. It has to do with liquid behavior. So a lot of hard to vary components, right, in that explanation. While temperature rise and therefore time interval temperature rising is not an explanation in itself. So again, theory comes first, explanation comes first. That's one part of it. And the other part of it is, in this scenario where you're going to say, I've tested this thing in 90 times, I'm 90 times more sure, or whatever that means, right? To be more sure about something. In reality, something is or something isn't. Something cannot be 50% something, right? So either the theory holds and it's a good explanation, or it's a bad one and it doesn't hold. So if you look at Newtonian thinking, for example, as well, they would have said, oh, Newtonian physics has been working for thousands of years. So every year, yay, it's good. We again, Newton wins, and all the predictions are coming true, and we're it's doing really good. And every year that goes on, it's like the Newtonian guys, they just add another check to we're more sure. And then comes Einstein and just says, oh, guys, Newton's wrong. Here's a better explanation. So how do you square that? How do you square being the most sure of something on day 1000 and then completely wrong on day 1001? Right? So I think these are also things that I equally was a victim of in my way of thinking. I also thought the more you test something, somehow the confidence level increases, whatever that meant, because I didn't critically think about what is the confidence level to begin with, right? It's just this intuitive thing. It's a very emotional thing. It speaks about how you feel about the thing. It doesn't really purport to reality, in a sense. So I think those concepts are important to kind of bring up as it relates to empiricism, as well as the Bayesian hoax, if you will.
Yeah,
So, yeah.
exactly. I think that also relates to, good explanation, bad explanation, being wrong, being right, and especially what is something that we haven't talked about yet, a good enough explanation. And when we talk about confidence or statistical significance, we say, oh, we're 95% sure that it works like this. But what does that mean to be 95% sure? And that's exactly the problem that Deutsch pinpoints. There's no such thing as being 95% sure. You're either sure or you're not. And if we only have data to be sure 95% sure, it doesn't mean automatically that that is the truth and that's the best possible explanation. But to make it a little bit more real, I really like the Newtonian thinking and the gravity example that's also described in the book. So Newton says, gravity works like a force. So an apple falls from a tree, and because of the mass of the earth, the apple is attracted. So there's a force working on top of it. It invokes a force, and that causes the movement of the apple towards the earth. Well, actually, the earth, of course, also moves to the apple, but that's negligible, and that's what we're taught in high school and also in college and in higher education. And it works good enough. It works in most of the cases, and we can measure that every day, and we can verify that every day. Every day, we can measure how gravity works. We can come up with 101 experiments, and they will all work, and they will all be true.
Yeah.
So it's good enough explanations for us to do most things, but not for everything. And then Einstein comes along and says, well, gravity is not a force. There is no force. Gravity is caused by massive objects that cause space-time to curve, and that causes the movement of the object, but not a force. So Newton is completely wrong. And it's kind of hard to wrap your head around, but that's a better explanation. And I think that's what you mean with the problem of empiricism. Even if we can do 101 tests, we test a specific theory, and we prove that it's right every single time. If tomorrow we have suddenly a better explanation, it will completely override it.
Yeah, this is actually like I'm sorry, was that you finished?
Go ahead.
That's one of like the most beautiful examples of showing why it's only relevant to test the theory when you have two good explanations for a given phenomena, right? So it's trying to solve the same problem, in this case, Newtonian and Einsteinian physics. It's just that, so up until, let's say, once Einstein came along, it's not like, we're like, yay, it's better, and now by Newton, and we still use it today, right? We use it within the scope for which it works. I think that's I'm kind of already hinting here at the answer is that it works for a certain scope of phenomenon that it describes to a certain degree of fidelity. Speeds under X amount of percentage of light speed, your margin of error is negligible as it relates to rockets and rockets and getting to the moon. Like if you're off by a millimeter, your rocket still lands, right? But once you go into very high speeds, like in relativity sense, like you're going 50% higher than the speed of light, you're not off by a millimeter anymore. You're off by meters. So it has to do with the scope of the thing it's purporting to address, the problem it's purporting to solve. In this case, I think it was Mercury. The orbit of Mercury actually did not fit Newtonian's predictions at all. It did fit Einstein's predictions. However, there was another possible explanation that would still have Newton be the right explanation, is that there was a shadow planet around Mercury that was causing its orbit. So you could actually, theoretically, using Newton's model, put an extra planet there, and then its orbit would still match Newton's predictions. After observation, there was no such planet. So it was refuted. Einstein won, Newton lost. But there was a moment where all bets were off. You didn't know which one was better because they were both solving the same problem. So you needed a specific case that you could refute one or the other. And this was before GPSs and stuff, right? So you couldn't, like, the technologies we have now came from Einstein, right? So again, you need the explanatory philosophy and the technologies that would actually use it. So now it's obvious to us because satellite doesn't work if you program it with Newtonian physics. It wouldn't get the signal in the right place at the right time. It actually would be off by like 8 meters or something, apparently. While using Einsteinian physics, you get it to a degree of like, 0.002 millimeters or something accuracy. So it's just crazy how much better the explanation is. But you can still use Newtonian physics to model relatively low speed phenomena. So it requires less computing time. So actually, it would make more sense to use Newtonian physics still than it would for Einsteinian physics, because you need less computational power, if you will, to put that all together. But that has to do with emergent phenomena again, also. But yes, you're absolutely right. You still use it. We still use it today. But
Yeah.
also Einstein will be proved wrong at some point. It's just the best explanation we have right now.
Yeah, with the current level of knowledge that we have right now. I think there are two important things there. And the first one is that it's not because there's a better theory out there that explains better, like the Einstein one, Newton, that the previous one doesn't hold any value anymore. Of course, as we discussed, Newton's laws are still used, are still applicable to the daily life, but also Einstein's relativity, because I can hear a lot of people thinking now, oh yeah, it's for high speed theoretical exercises, or maybe, like orbits of black holes or whatever. That doesn't really have any implication on their day-to-day life. But that's not true. Huh? You said the GPS example, and we're not going to go too much into detail, because as we discussed before, if you're close to a massive object like the Earth, or if you're far away from a massive object like in outer space, time will impact you differently. So if we have a GPS satellite orbiting the Earth, because it's a certain distance away, it's less affected by the gravity as we are, time actually goes different for the satellite than it goes for us. And that absolute, and it's a small difference. I believe it's just a couple of milliseconds, or even a couple of thousandths of. It actually impacts, and it creates a big error in the signal and the prediction of the satellite. So without the correction of Einstein's law, the satellite GPS would just not work for us. It would be completely wrong. So it does absolutely have an impact on our day-to-day life without us thinking about it.
Yeah, it has more to do with the speed of the signal than it does with the speed of the satellite, by the way. The speed of the satellite isn't big enough to cause special we put those satellites into orbit using Newtonian physics. The Einsteinian upgrade comes with the speed of the signal,
Okay.
versus where if you would plot it coming from the satellites using Newtonian physics, by the time, because of the time dilation of the signal, because it goes at light speed or what close to, it actually hits a different place on Earth than it would actually do using the right framework, being Einsteinian physics. So that was just a nuance there that I wanted to clarify, as well as also something you said before that I wanted to pick up on. You said something's on 95% accurate, something like that, right?
Yeah.
I would say it's so ingrained in our way of thinking that we almost don't realize we're doing it. Same goes, and I think the weather is often like a very good day-to-day example. Like, and this ties to kind of the Bayesianism and the empiricism, and kind of, let's say, probabilistic way of thinking, where you can say there's a 95% chance of something happening or something not happening. So again, either it rains or it doesn't. There is no such thing as 95% rain. So people will say, yeah, that's all good and well, but you know what we actually mean. Like, do we pack an umbrella? Yes or no, right?
Yeah.
And then it's like, yes, but let's review here actually what these percentages are saying or purporting to say. So if you poll people and you ask them, what does this mean? 50% chance of rain. I will ask you now, what do you think that means?
50% chance?
Yeah.
Yeah.
What does that
Well,
mean to you? Like just intuitively.
well, if you do it once, the the outcome will be right half of the time. But that also implies that if you repeat it, that it would still be 50%.
Repeat what?
Yeah, anything. Let's say coin toss.
That's an interesting example, which also Deutsch addresses, by the way.
Yeah.
But just to come back to the weather thing, like what does it mean to you that if you look and before heading out, you look on your phone, it says 50% chance of rain. What
Then
does that mean to you?
then I will take my umbrella because there's 50% chance of rain, which is high enough for me to pack an
But what does
umbrella.
it? But what do you think that 50% means? 50% of what?
Yeah, there is no 50% of anything. There is a fairly large chance that it's gonna rain, and that's
Yeah,
it. But
but why? Either it rains or it doesn't, right?
yeah, I understand what you're getting at. That's why, and I think your point is we assume that 50% actually says something, actually means something, but it
It
doesn't.
does. It does mean something, just not what
Yeah,
we think it does. So a lot of people, when you poll, what do you think it means? 50% of what? They go, there's a couple of answers that come. 50%
yeah.
of weathermen say it's going to rain.
Okay. Yeah.
50% of the surface area
Oh yeah.
is going to be affected.
Yeah.
50% of the time it will be raining of the day.
Yeah.
Like there's a couple of these things that people then think it could mean.
Yeah.
But what it actually means is based on all the modeling,
And the
all the
data.
models,
Yeah.
mostly the models, because you don't have data of the future. So anyway, so weather is intractable. Probably the equations you need to solve weather for are most likely intractable, making it almost impossible to compute what it would actually do. It has to do with certain interchangeable. Well, they were. I forget. I'm not gonna. Let's not get into that. But anyway, it may be so difficult to calculate that it would be impossible to do with the amount of resources for computation that we have in this universe, even the multiverse potentially. But then coming back to what 50% means, it means that 50% of the models that model the, let's say, the patterns of weather and the um, winds and all that kind of stuff, they give 50% of the time rain. So let's say you run 100 simulations, 50% of the simulations show rain. That is what that 50% means. Because even in the model, either it rains or it doesn't.
Yeah.
Right? So in this is a very, very profound misconception that we have about chance and probability, which doesn't exist. Probability does not exist. And that in itself is like a 5-hour conversation because it's so ingrained. But I wanted to tie that back to confidence levels and stuff like that, because you do not make decisions based on probability. Even the model, right, that they're rendering the weather on has been explained by the programmer that modeled the model, right? So there are assumptions in that model. And those assumptions in the model lead in 50% of the simulated cases to rain and 50% of the simulated cases not to rain. That is that. So what would you do if you see on the weather there's 50% rain? You look out, it's looking very dry. There's no cloud to be seen. You like there's more than just looking at your phone, right? That
Yeah.
will drive your decision making process. So the same goes for weighing your options. Nobody weighs their options. There's this economical thinking that Homo sapiens do rational weighing of certain things and somehow come to then what is the kind of the the 50% of the thing that that does for you kind of situation. You know what I'm talking about, right? Where purportedly, if you're making decisions, you kind of weigh the percentage of the value of each kind of option, and then you put those against each other, and then you choose. But that's not what we do at all.
Yeah.
There's no such thing. There's no such mechanism that happens. We choose what's the best explanation for us in that specific problem. You know, let's say that problem. What's the word I'm looking for? Yeah, problem situation.
Yeah. Yeah, I think an example of what you mean is there's another book that we're not going to get into, and there was a beautiful example of how the mind works and how people don't think in weighing options and statistics. And it's about a caveman. He's outside hunting, and then there are some shrubs, and he hears some noise in the shrubs. You know, that person is not going to weigh, oh, this might be, it might be nothing, and I just have to stay here. There's nothing going on. Or it might be a predator, a saber-toothed tiger or whatever. It's going to jump out and eat me. No, the mind is evolved to make a split-second decision. And in most cases, the caveman will just run away. He's not going to weigh his options, because even if there is a slight chance that it's a predator, he will get attacked and he will get eaten. So the brain doesn't work like that. He's just gone. And the best possible explanation at that moment is there's a predator, or there might be a predator, and I need to get out of here right now. So there's no weighing of options whatsoever. Even though we believe that we weigh options and that we think that we operate and make decision making in such a way, it is typically not true.
We don't.
And it's a very important misconception, I believe.
Yeah, no, it's completely false. There's nothing maybe not true about it. It's completely false. There's no such thing, because there's creativity. We can literally come up with new solutions for things. We are not bounded by the ABC, like option 1, 2, 3 in front of us. We can choose not to do any of that stuff. Like a human could choose to ignore its kind of instinct in a bush rattling case, and by the way, that would be more culturally taught. I think I don't think that's necessarily DNA knowledge. I think that may be cultural knowledge, because if you hear bush rattling and it was never dangerous for you as a child, I don't know if you'd like, I don't think that's an evolutionary trait.
Yeah.
So I just wanted to correct that as well. But it has to do more with like situations where your fight or flee is not like your base, kind of somebody hits you, you say ow, right, from a reaction. Like there's kind of these inborn knowledge that we have, and then there's the learned knowledge that we have. And it goes to that degree that, these models about how we make decisions have been created by economists and stuff like that. But it's all wrong, because we don't think that way. We just don't do it. It's like you don't even have to go out and try to refute it, because it doesn't happen. That's also kind of what inductivism is about as well. It's like, let's not confuse whoever may be listening to this at some point.
All right.
Okay. Yes. So to come back to explanations, and maybe a little bit of a tangent here, I wanted to bring up the fact that we always. So I'm also taking a quote here. See if I can find it. So it has to do with explanations and the seen versus the unseen. Okay, so every explanation is a theory, and every theory is an explanation. And in the end, they explain the seen in terms of the unseen. That's very, very important, because the fact that we've never been to the sun, right? I mean, there's no amount of technology that we could send there that would survive getting to the sun. Yet we know what the temperatures are there, right? We know there's nuclear fusion, yet nobody has been there to see that happening.
Yeah.
Right. So that has to do with the fact that every explanation every explanation is always purporting to explain something seen, the observation, let's say, but even that implies an explanation, because there is no such thing as a theory-free or an observation-free explanation, let's say. It's your cat is funny.
Yeah, he wants to join in on the conversation.
Nice.
Yeah.
So even the act of observing implies an explanation. But let's say we know what we're talking about, right? You see the sun go up and sun go down. So you're explaining that through the unseen, which is, gravity and, in Einstein's case, space-time curvature, your nuclear fusion to explain the sun heating up, like the planet, our planet, kind of going around its own axis, all that stuff you need, which is unseen because you're standing on the ground, you don't see that moving, right? So a very good example is dinosaurs. We've never seen a dinosaur. Nobody's ever seen a dinosaur. Maybe in the future we will if we reverse engineer and, like Jurassic Park it, right? But nobody has ever seen dinosaurs, nor do we see the bones of dinosaurs. We see what is now residue that were bones from dinosaurs. And people tend to take that for granted, right? But then somehow the empiricists, they think that you can observe your way to a theory. You can observe yourself to a new explanation, but you cannot. Explanation comes first, and they always purport to explain the seen in terms of the unseen. Also, was an important one that I wanted to mention.
Yeah, it's an important insight from, I believe, the first chapter. To wrap up the first chapter, because we talked about a lot about knowledge, and in essential, if we talked about what the book is, what the title means, and what the impact is. But to summarize it, the book is basically about, in my opinion, about knowledge, and that is something that a lot of people take for granted and not a lot of people think about. And knowledge is described as this very, very powerful tool, this powerful concept that impacts, of course, our daily life. So we live in houses and in buildings. Why? Because we have gained knowledge over the years on materials and insulation and how to build them. It is not that people in the past were more stupid than us. They were great thinkers thousands of years ago. The first Greek philosophers, they just didn't have the knowledge, the same knowledge as we had, and that's something that accumulated over time. The same goes for driving cars, flying planes. All of that stems from knowledge that's building up. But we also said that we shouldn't extrapolate, but I'm gonna extrapolate. If we extrapolate the accumulation of knowledge and the increase of knowledge and scientific discovery and innovation into the far future, and that's how chapter 1 ends, is that it's I believe chapter 1 is called the reach of knowledge. The reach of knowledge is so large that this is just like a supermassive black hole. It has the power to transform an entire galaxy.
Yeah.
We as humans have the knowledge to transform our planet. We've talked about that. We built roads and cities and impact the entire atmosphere and climate change and so on. But with more knowledge and time, we have the potential to transform the entire galaxy. We can colonize different planets, absorb energy from every single star in the galaxy. And if you think about it, what can transform an entire galaxy? It's not only supermassive black holes. It is actually knowledge.
Exactly.
And that's a very interesting insight. And that's also one of the mind-blowing things from the book. And it's something that I never thought about until reading that book.
Yeah. That is a philosophical discovery of Deutsch. He and it's one of the quotes that come to mind is from Deutsch is, if it is not forbidden by the laws of physics, then it is achievable given the right knowledge.
Yeah.
So either the laws of physics allow it, and therefore it's merely about applying the right knowledge to get that thing to be. Because if you couldn't do it, that would be against laws of physics. And a good example is going faster than the speed of light in space-time. In space. But space, for example, doesn't obey those same laws. Space can actually go faster than the speed of light. It's light through space that cannot exceed the speed of light. But so that's an example where we're bound by those laws. We cannot, no matter the amount of knowledge that we are going to apply, we will never be able to go faster than the speed of light in space. Those are the bounds set by our universe, which we should be able to explain. It's just going to require what they call a different mode of explanation. It's like, and that's what he's doing here. Deutsch, he's providing a different mode of explanatory, of explanations through looking at knowledge in its own right, which is also called epistemology. It's like epistemology means the history of knowledge, or the thinking of thinking, if you will, in a sense.
Yeah.
And I love that stuff. And epistemology, so is one thing, is our knowledge of something, and then you have the ontology, which is the thing itself. And it took me a while to really be able to square those things together, because the ontology is, let's say, that's reality. That's the actual thing that's going on. Let's say describing the ball with its trajectory, right? The ball is still moving in reality. It's just when we had Newtonian physics, we had the knowledge of it from that angle. And then with Einsteinian physics, we had the broader angle. But it's still the same ball doing the same thing, right? So that is the ontology, if you will, the concept of what is actually out there in reality. And then the epistemology is our knowledge of the thing.
Yeah.
That we create. It is not deduced from nature. It is not induced, from nature. We do not read the book of nature. It's not like Newton, like the concept of this force was revolutionary in his time, right? He had to creatively come up, conjecture this idea of force. Genius thing to conjecture. It was wrong, but it solved a lot of problems applying that thinking. So I think making that distinction between our knowledge of the thing and the thing itself will help in developing an understanding of Deutsch's philosophy. Is that we're trying to get closer to the thing, but we will never get to the thing, because we will always be a new problem to solve, because reality is infinitely complex, but it's also infinitely perfect. Reality has no inconsistencies. Our knowledge does have inconsistencies that require better explanations. And that is infinite, at infinite. Progress is at infinite that way. So I also found that a super profound insight. Like I'm starting to see knowledge as like this, like I've like a gun or a bazooka with knowledge in it, and he, like, you just have to aim it at something, and then you can transform it into an intergalactic highway, right?
Yeah.
And that's kind of how it is. It started in our minds, right? Like the idea, like a bridge is a really good example. You have a bridge, you write it out, and then you construct it. You test it against reality. If your model of the bridge structure works, and maybe you didn't write it up like we now would write it up, and maybe it was like the Egyptians or whatever. I'm not familiar with the history of bridge building, but I'm sure the first guy had an idea, set something up, and then it fell down, and that was testing it against reality. He had an idea that he creatively came up with, put that into reality, and then either it failed or it didn't fail. It fell. It stood up or it fell, and maybe over time, things would happen. He would need to upgrade the knowledge of the bridge. Right, bridges now and what they were thousands of years ago are not the same. There's a lot more knowledge. So that, and I'm saying this specifically because in the bridge is the knowledge. You know what I mean? Like it contains the knowledge. And those are insights into Deutsch's philosophy that I'm only now, since the last month, really starting to come to terms with. Is that so he defines knowledge as information that you can I forget what he actually uses the word, but it's information that can be contained in different mediums,
Yeah.
and would want to cause itself to sustain itself. So it wants to stay. It wants to stay. Like DNA, it once it was there, it wanted to stay and replicate, and DNA is knowledge as well. So to the best of our knowledge, we have two types of knowledge. We have DNA, which is kind of more the first level knowledge, if you will, kind of the simple, but it's still knowledge. There's knowledge in there. And then we have our type of knowledge, which is explanatory knowledge. We actually can go out there and explain things using creativity. And by the way, we have no idea what creativity is or how it works. We have no knowledge on that currently. But I do think that David Deutsch's philosophical discoveries about knowledge and about what person is, about what creativity actually is, will help in that journey to gain an understanding of what creativity is. And same as with any explanatory theory, that you have that aha moment, right, where you go, that's why, that thing, that is creativity. Like your mind is constantly like conjecturing. You're doing this probably like 1,000,000 times per second, or whatever that number is. It's not a number that I know about. It's just you're constantly testing your ideas against reality. From the moment that you pick up a glass, it's like because you think that glass is there, but until you're there, maybe it was an illusion. Maybe there is no glass, right? So until then, you're going to assume that your explanation that there is really glass is the right thing, until maybe you wake up and you were in a dream, for example. So there's that profound insight where it has to do with creativity, explanatory knowledge, and it has to do with what we are as people, which we don't understand. But that's the avenue through which, and that's only possible because he has put knowledge central. It's it's a whole thing that we will need to discuss, because it is central in his let's say world philosophy, in his epistemology, is that knowledge in itself obeys the laws of physics. There is a law of physics about knowledge, because it is part of reality. Therefore, it must obey the laws of physics. Else, it's not part of reality. And it goes into abstractions as well, like mathematical equations that you cannot test in reality. You cannot test them in the same sense as a flying rock. You can test that trajectory, but you can still test it against abstract reality, which also exists. But now we're getting ahead of ourselves, I think.
All right. I think those were great closing words on this first episode of Chapter 1. Let's continue the discussion about knowledge and what it means in our next episode of this podcast, which we dubbed Error Correcting Erik's Journey to Eternal Knowledge. So I want to thank...
And beyond.
And beyond. I want to thank you a lot for this conversation, and see you next time.
Sounds good.